For which n greater than 0 does that expression equal n squared? Okay, well, I looked at this and they look all the same to me, so it looks like there's 4 of them. So 4 of those guys, which are 3 squared plus 4 squared, and that is n squared. So we can combine them pretty quickly. Well, the 3 squared plus 4 squared in the brackets, that's 9 plus 16. And the 9 plus 16 is 25. So we have 4 times 25, which is 100. And if 100 equals n squared, that means n is the square root of 100. And they want only the positive 1, so that would be just 10. What is the largest possible area of a rectangle whose integer sides, with integer sides and perimeter 22? So we have a rectangle. So we got, let's label it A, B, and B. Okay, so the perimeter would therefore be 2A plus 2B. And they're saying that is equal to 22. So if you divide through by 2, you get A plus B is equal to 11. Correct? Okay, so now we want the area. The area of this is A times B. And we want the largest possible. So we'll make a little table here. So we got what can A be, what can B be, and therefore what will AB be? What will be the value of A times B? And keeping in mind that A plus B has to equal 11. So it's just experimentation at this point. And they're all integers, so that obviously makes it very, very helpful. Okay, let's start with the smallest possible value of A, which I think is 1, because that's the smallest integer. If A is 1, then B is 10, because remember, they all have to abide by that rule. And therefore, A times B would be 10. And that's basically what we're doing here. So 2, 9, that's going to be 18. 3 and 8, that's going to be 24. 4, 7, 28. 5 and 6 would make it 30. And then 6 and, I think 6 and 5 would again make it 30. And then we get to 7 and 4, 28. Okay, so now it's going down. So obviously 30 is the largest possible area for the conditions required. If 1 over x plus 1 over y over 1 over x minus 1 over y is 2003, what is the value of x plus y over x minus y? Okay, so a bunch of algebra here, so let's just do that. Get a common denominator, y, x. So that becomes x plus y over xy over y minus x over xy. Okay, so if we invert and multiply this guy, we will have x plus y over xy times xy over y minus x. Now these two guys cancel, so then you just get left with x plus y over y minus x. And that's it. That's all we have left. Now that looks similar to this, but not exactly. So we want to make it similar. How do we make it similar? Well, I think all I have to do is just multiply by -1. If I multiply both sides, in particular the denominator, so if I go 1 over -1 like that, and of course I have to do that to both sides, well, the left side becomes x plus y over x minus y, and the right side becomes negative 2003. And that's it. That is what this is. So the answer is negative 2003. Together, Al, Barb, Cal, Di, and Ed earned a total of 150, but in unequal amounts. In order to equalize their earnings exactly, first Barb gave half her earnings to Al, next Cal gave 1/3 of his earnings to Barb, then Di gave 1/3 of her earnings to Cal, finally Ed gave 1/6 of his earnings to Di. How many dollars did Al have before equalization? Okay, so let's see here. We'll just call them A, B, C, D, and E. And initially, their total is 150. And when they're equalized, they would have 150 divided by 5 each, which would be 30. So 30 is, I guess, the end goal? Yeah, because initially it was unequal, and then later we equalized it. Okay, so we've got to do some calculations here. It shouldn't be too bad. Okay, so let's see here. Let me see if I can do this without confusion. Okay, so initially we have let me read this again. First, Barb gave half of her earnings to Al. So that means half is gone, so we're remaining with B over 2, and then that B over 2 goes to Al. So that takes care of the first one. Okay, next, Cal gave 1/3 of his earnings to Barb. So he gets left with 2/3, and then 1/3 goes to Barb. 1/3 C. Okay, and then that takes care of that one. Di gave 1/3 of her earnings to Cal, so she is left with 3D over 4, and then that 1/4 goes to Cal, so Cal then gets that D over 4. So that takes care of that one, and then the final one, Ed gave 1/6 away to Di, so he gets left with 5/6, and then the 1/6 therefore then goes to Di. Okay, I think that completes the equations. And then now all of these have to equal 30, so then we have to solve, and then eventually we have to solve for A because we want Al's. So we got 5 calculations. So here we go. So this one is 30, so that means that that's going to be, E would be 36, I believe. Yeah, 36. If you calculate E. Okay, so sub that into here because this whole thing is 30 also. So that means that's 3D over 4 plus 36 over 6 is 6 is 30. So that means 3D over 4 is 24. So that means D would be 32. Or let's see here. Yeah, D would be 32. Okay, moving right along. Hopefully I did that correctly. And then now we got to put it into here. So 2 over 3 C plus D is 32. So 32 divided by 4 is 8. And that whole thing is equal to 30. So that means 2C over 3 is equal to 22. So that means C is 33. Okay, put that over here. So now B over 2 plus C over 3 is 11. And that equals 30. So that means B over 2 is 19. So B is 38. And now finally we get to what we actually need to do, which is A. A plus B over 2. B over 2 would be 19, and that's 30. So therefore A would be 11. And that is what Al had before equalization. If x is greater than a half, find the simplest radical form expression for that. Okay, so we got 1 plus 2x minus 1 all under the root. And then we have the big root x plus, again, 2x minus 1. Okay. I am going to make a substitution. 2x minus 1, I will let it equal a. And therefore, it looks like a plus 1 over 2 is x, and perhaps we will need to do that. And before I substitute it in, 2x minus 1, actually, is that the best thing to do? I don't think so. I think the best thing to do is maybe make it a squared. Yeah. Because that way then, if I took the square root of that, it would be the square root of a squared, which would be a. Yeah, I think that's probably the best substitution, just to make it as simple as possible. So then, therefore, this thing with the substitution would be 1 plus a over, well, now I got to put in x. What's x? Oh, x is here. I got it. I already did it, and then I forgot. A squared plus 1 over 2, and plus that, which is a. Okay, that I don't know if that helps, but I hope it helps. Okay, so let's see what we do here. The top is pretty good. The bottom, let's do that. That's going to be a squared plus 2a plus 1 over 2. Aha! Okay, that is indeed very, very good. Because some of you already see what's going to happen here. Okay, so we got 1 plus a. On the bottom, this guy is really just a plus 1 all squared. So that a plus 1 all squared, when you take the square root, is just a plus 1. And then when you take the square root of 2, it's just root 2. So then finally, this would be 1 plus a over 1, root 2 over a plus 1. And then that just becomes root 2 because the 1 plus a's cancel. So very nice. Regardless of what x is, that always simplifies to root 2. The length of each side of a certain right triangle is the reciprocal of different integer. What is the least possible sum of the three integers? All right. So we have some right triangle, and so we've got a situation like, let's say this is 1 over a, 1 over b, and 1 over c, because the side lengths are a reciprocal of a different integer, where a, b, and c are integers. Okay. So what? Where do I go from here? All right, well, I guess the obvious, which is I have to take advantage of the fact that it's a right triangle. Yeah. So, And we will first do this with letters and then with numbers, or it doesn't really matter which order you do it with, but I'll do it with both in order to make it not as confusing. So first let's do it with letters. Let's say we have 3 numbers, okay, a, b, and c. And what we need to do is obviously try to find a relationship between the sides. Now, if I divide through by ABC, so if I go A divided by ABC, B divided by ABC, and C divided by ABC, that's going to give me 1 over BC, 1 over AC, and 1 over AB. Now these are going to be the side lengths. So for example, this will be 1 over AB, and this could be 1 over BC, and then this would be 1 over AC. And then therefore, because it's a right triangle, 1 over BC squared plus 1 over AC squared is equal to 1 over AB squared. Okay, so now let's see if I try to get the common denominator. AC C squared plus B squared C squared all over, what did I do here? Well, I multiplied top and bottom here by A squared C squared. Yeah. A squared C squared. And then here I multiply top and bottom by B squared C squared. So that's how I got A squared C squared plus B squared C squared. And then on the denominator I'd have, let's see here, A squared C to the power of 3 B squared. And then on this side you'd have A squared B squared. Okay. So let's clean this up a bit. Let's see, A squared C squared plus B squared C squared. If I cross multiply, I'd get A squared C cubed B squared over A squared B squared. So that looks to me like it would be, I don't know why I put cubed there. This is obviously not a cubed. This is a fourth. Yeah, because I forgot to square it, that's why. So that's a fourth. Okay, good thing I noticed that. So then this basically becomes, let's see here, the A squareds cancel. So this just becomes C squared. To the power of 4 is what I meant to say, not C squared. I don't know why I keep doing that. Maybe there's just too many 2's and I'm getting confused. Okay, so that's what we come down to. And then when you get rid of all the C squared, you get A squared plus B squared is equal to C squared. Aha. So that means that if I start with 3 integers, those three integers satisfy a Pythagorean relationship in order for this to hold true. Okay, so that's actually very interesting. Okay, so now let's do it with integers. The exact same thing that I did here, but let's do it with some integers. And that way, hopefully, it won't seem as abstract. Okay, so exact same thing. Let's start off with three integers, but remember, we have already shown that those three integers are going to be a Pythagorean triple. So let's start with the basic one, the 3, 4, 5. That's the most common one, smallest one, right? Okay, so the next step would be to divide by the ABC, and in this case, ABC is 3 times 4 times 5, which I believe is 60. So let's divide through by 60. And when we do, we get 1 over 20, 1 over 15, and 1 over 12. So that's this guy here. So making a little parallel. And then, because it satisfies that, this basically, let's draw it again. This is my 1 over 12, this is my 1 over 20, and this is my 1 over 15. So it satisfies 1 over 20 squared plus 1 over 15 squared is equal to 1 over 12 squared. And this is indeed true. You can, calculate it and verify it for yourself that it is indeed true. Now, finally, we want the sum of those three integers. What are the three integers? Well, the three integers are these guys. This one, and this one. So it's this, and this. So the sum of those guys, well, that's pretty obvious, is this. And that's going to be 47. And they wanted the least possible one, and the least possible one is obtained by using the smallest Pythagorean triple at the very beginning.